delta is the Greek letter, or this is the symbol for the small letter of the Greek alphabet, delta. And let's try this a little bit better. This here is the small letter epsilon in the Greek alphabet. These are called delta epsilon truths that we're going to do. Now, basically, when we said the limit as x goes to 3 of 2x plus 1 is 7, because when I let x be 3, I get 6 plus 1 is 7. That's a little bit hand-waving. I mean, why can't we say, for example, instead, the limit is 6.999999483? Because again, like I've always said, x can never be 3. What happens when x gets really, really close to 3? Can the limit be 6.999999483? Okay, because when x is really close to 3, you multiply that number close to 3 by 2, and it's not unreasonable to say this is what I get. It's not unreasonable to say, well, when I take a number close to 3, I get this number here, and then when I add 1, I get 6.996 times 483. Exactly this number. It's not unreasonable for somebody to say, well, why is this not the answer? Or somebody can say 7.000000314. X is really close to 3, but a little bit more. When you double it, you get a little bit more than 6. Add 1, get a little bit more than 7. Why is that not the limit? So let's argue it from a very strong viewpoint and let her see what happens. Okay, so if we have in general the limit as x goes to some value, call it c, of some function equal to L. An example might be the limit as x goes to 2. C is 2. And the function might be, 3. And the function might be 2x plus 1. And the limit is 7. Well, so we'll keep coming back to this. But what does the top line mean? It means that whenever x is close to c, then this is close to L. If x is really, really close to 3, then this is close to 7. Whenever x is close to 3, then f of x is close to 7. Excuse me, close to L. Whenever x is close to c, then f of x is close to L. That's what this is saying. Now, how might I say x is close to c more mathematically? Now, here is c. If x is close to c, it's around c. Call this neighborhood or length delta. And this is also delta. So this x value at the end is going to be x. Something's disturbing me. Okay, so let me erase this. This x value right here would be c take away delta. For example, if this is 7, say away from 7, if this is 8, and I tell you this distance is 5, will be whatever 8 minus 5 is, namely 3. Here, C here, and I'm going to the right delta. So this moss will be C plus delta. Okay, so whenever x is close to C, so x is in C minus delta, comma, C plus delta. X is in between that. That is, x is in between C minus delta and C plus delta. But we can say that a little bit differently. I wish I didn't run out of room. I'm going to come here. We can say that a little bit differently. If we take away C from all three sides, if I take away C from all three sides, when I take it away from the left, it's not there. I just get negative delta. When I take away C from the middle, I get x minus C. And when I take away C from the right side, I just get delta. But if this is in between plus or minus some value, plus or minus delta, we can say that x minus C is less than delta. That is, this means, so I'm going to keep the word whenever x minus C is less than delta, then, and now we have to come back and talk about what does it mean for f of x to be close to L. And delta is some small number. Well, f of x is like x, and L is like C. So what I'm going to get is very similar. Instead of x, I'm going to have f of x minus. Instead of C, I put L, and I call this epsilon. So let me write this down here, and then erase the nonsense I just wrote. Okay. Whenever, so this here on top, it means this. Whenever x minus C is smaller than delta, then f of x and L is smaller than epsilon. Now, let's look at it one more time from a different point of view, and let's see what happens. And remember, we don't care what happens at C. So I claim that the limit as x goes to C of f of x is equal to L. So maybe here is some function, and here is C. And even if it's an open circle here, L is going to be that value. Why? Because no matter what neighborhood I pick around C, the image, that is f of these numbers, will always lie in between here and here. Okay, in fact, if I pick a neighborhood around L, if I reverse the game, and I pick the neighborhood around L, because we're questioning whether L is the right answer. I claim that I can get the limit as close to L as I want. So, I pick an epsilon. I say that this distance is epsilon. So this value will be L plus epsilon, and I go epsilon below, and this value will be L minus epsilon. Well, how can I get that close to L? Well, if I picked I just don't like the way my graph is. I'm going to keep everything the same, but it changed the graph a little bit. That's the graph. So here's L minus epsilon height, and here's the point that gives me y as L plus epsilon, and here's my interval. If I stay within here, if I keep my x's that close to C, I guarantee you I'll get close to L. The smaller epsilon is, the closer I get to L. Anyway, the formal definition is as follows. The way to prove this is as follows. You understood all that? Great. Yeah. So, to prove that the limit as x goes to some number of this function is that number L, you must show the following. You must find a positive delta. Well, that's not true. Give me one moment. Given any epsilon, I don't know what I was thinking. Given any epsilon greater than 0, you must find delta greater than 0 such that f of x minus L is less than epsilon implies, guarantees, that x minus C is less than delta. Okay, you must show that. Alright, so for example, suppose I say show or prove that the limit as x goes to 3 of 2x plus 1 equal to 7. Remember, this is C, this is L, and this is f of x. Okay, so I must show that. But here's the proof. TF for proof. Given epsilon greater than 0, we must find delta greater than 0 such that this statement is true. F of x, which is 2x plus 1, f of x, minus L, which is 7, in absolute values, is less than epsilon. That implies x minus C, C is 3, x minus 3 is less than delta. I want to find out what to call that delta. Well, 2x plus 1 minus 7 is really 2x minus 6. And we want this to be less than epsilon. We'll state that in a moment. Now, what I want to do, and this is what you need to catch on to, I want what's in the brackets, in between the absolute value bars, to be exactly this. Exactly. That's the whole goal. Get it to be exactly this. Well, I can factor out 2. In fact, there's a theorem that says the absolute value of A times B is the absolute value of A times the absolute value of B. So this is equal to the absolute value of 2, which is 2, times the absolute value of x minus 3. But that's this. And I'm claiming that this is less than epsilon. Now here it is. This statement right here, is exactly the same as, is equivalent to x minus 3 is less than epsilon over 2. Okay, x minus 3 in absolute value is epsilon over 2. Okay, now, if I want this to imply that, well, if I replaced delta right here with epsilon over 2, that is, the left side of my implication is this. X minus 3 is less than epsilon over 2. Does that imply, I'm copying the right-hand side, except instead of delta, I'm going to put epsilon over 3. Does that imply that x minus 3 is less than epsilon over 2? And the answer is, of course. They're exactly the same statement. Okay, they're exactly the same statement. So what you do is you choose, remember we had to find delta, you choose delta to be half of epsilon. And that's the answer. I found my delta. Yes, delta is a function of epsilon. Let's try some more. And then after we do a couple of proofs, I'll show you what it means. Say delta is epsilon over 2. All right, so prove that the limit as x goes to 5 of 3x minus 2 is equal to 13. Okay, so proof. This time we have more space. You must show, and you have to write this. Okay, excuse me. You have to write this. Given epsilon greater than 0, you must find a delta bigger than 0 such that f of x minus L, which is 13 in absolute values, is less than epsilon. Guarantees, that means implies, that x minus c, which is 5, is less than delta. Okay. Well, this here is really 3x minus 15. We want to show that this implies x minus 5 is less than delta. That is, these last two lines are exactly the same. The third line I'm about to write, the next line, is going to be the same as these two. I'm going to say that 3x minus 5 is 3 times 3x minus 15 is 3 times x minus 5. So the absolute of 3 times x minus 5 is the absolute value of 3, which is 3 times x minus 5. And this is less than epsilon. We want to show that that implies that x minus 5 is less than delta. Like I said, on the left side, in this area here, I want to get just that. So divide by 3. X minus 5 in absolute values is less than epsilon over 3. That implies, we want that to imply that x minus 5 is less than delta. For example, if this were 10, isn't it true that if x minus 5 is less than 10, that implies the absolute value of x minus 5 is less than 10? Doesn't it imply that? A statement implies itself. If you have $10 in your wallet, that implies you have $10 in your wallet. It also implies that you have $9 in your wallet. Okay. With this last line, not part of the proof. So remember that as long as these two are both the same, we want these to be the same. And that's what the line that remains after I delete the That's what the last line that you see says. It starts off with the same thing. Less than this, less than that. Just choose, and literally write this, choose delta to equal to, choose delta to equal to epsilon over 3. In fact, you might say choose delta of epsilon, because delta depends on epsilon. To get an exact number for this, you need epsilon. If epsilon was 6, then epsilon over 3 would be 2. So delta is a function of epsilon. Epsilon over 3. Let's try another one. Suppose I ask you to prove that the limit as x goes to -2 of, I don't know, 4x plus 10 is equal to 2. Well, what we can do just to verify it, 4 times -2 is 8. You add 10, you really do get 2. But it asks you to prove it. Whenever they say prove that this limit, that the limit of this function is equal to that number, they're talking about a delta epsilon proof. So we must show that given any, if I haven't been writing the any, I was mistaken, sorry. Given any epsilon greater than 0, you must find delta greater than 0 such that, this small 3-letter word was important. You must find delta greater than 0 such that the absolute value of the function 4x plus 10 minus the limit 2 in absolute value is less than epsilon guarantees that x take away -2, better known as x plus 2, is less than delta. So I want to get this to just be the absolute value of x plus 2. Once you start catching on to that, these problems are simple. 4x, 10 minus 2 is plus 8. This is less than epsilon. We want to show that, guarantee that. But so here I'm going to factor out 4. It's the absolute value of 4 times x plus 2. And that's less than epsilon, and you want to find delta that implies that x plus 2 is less than delta. But this 4 can come in front. This is 4 times the absolute value of x plus 2, less than epsilon, implies x plus 2 is less than delta. Divide by 4. X plus 2 in absolute values is less than epsilon over 4, implies that x plus 2 is less than delta. Oh, if this said epsilon over 4, this is less than epsilon over 4, implies that this is less than epsilon over 4? Absolutely. Okay, so the last line, and I run out of room, the last line should be choose delta to equal this, epsilon over 4. Okay. Let's do one more. This one's going to be a little bit harder. See if I remember how to do this one. Suppose you wanted to prove or prove that the limit as x goes to 2 of x squared is equal to 4. So, proof. Given any epsilon greater than 0, you must be able to find you must find a delta greater than 0 such that f of x squared, minus the limit for an absolute value is less than epsilon. That implies that x minus c, an absolute value, is less than delta. Now, I can factor x squared minus 4. It becomes x plus 2 times x minus 2. Less than epsilon, and the rest is the same. Now, I can even break it up. The absolute value of x plus 2 times the absolute value of x minus 2. This is less than epsilon, and that implies the absolute value of x minus 2 is less than delta. Now, so let me actually write that down. X minus 2 is less than delta. So I want the other side to have, on the left side, that is here, I want it to only be the absolute value of x minus 2. But the thing is, it isn't. It's x plus 2. And what is different between this problem and all the others? X plus 2 is not a constant. So what you do is you put a bound on delta. Choose delta to be less than some number. Always choose 1. It's the simplest number. So then the right-hand side says that x minus 2 in absolute values is less than 1. That is, x minus 2 is in between negative 1 and 1. Now, I want to find the bound on x plus 2. Well, add 4 to both sides, all three sides. Why am I adding 4? Because in the middle, x, so let me write this up here, please. I have negative 1 is less than x minus 2 is less than 1. If I add 4 to all three sides, what happens is the middle becomes x plus 2. It's less than 5, and it's bigger than 3. Okay, it's less than 5, and it's bigger than 3. That means that x plus 2 in absolute values is less than 5. Okay, so now I'm continuing underneath, but I have to write up here. So we just learned something. This here, we just learned something from this. If delta is less than 1, then we learned that x plus 2 is less than 5. So, the absolute value of x plus 2 times the absolute value of x minus 2 is less than epsilon. Okay? But now, if I put something even smaller here, it'll definitely be less than epsilon. For example, 10 times 8, 80, is less than 90. 80 is less than 90. And if I make this number even smaller, like 7, isn't 7 times 8 less than 90? So if I make the left side even smaller, well then of course it'll be less than epsilon. Because epsilon is bigger than the left side. Epsilon is bigger than the right side, the left side. Epsilon is bigger than this. So if I make this even smaller, epsilon will still be bigger. But I know that x plus 2 times x minus 2 is less than 5, so this is less than 5 times x minus 2. I just put the most that x plus 2 can be. So this is still less than epsilon. Okay, so dividing both sides by 5, x plus 2 is less than epsilon over 5. And I want this to imply that x minus 2 is less than delta. So I choose delta to be this. Almost. Because remember, delta has to be less than 1. just in case epsilon over 5 is more than 1, I'm going to say choose the min, the smaller of epsilon over 5 and 1. That is, if epsilon over 5 is bigger than 1, I'm going to choose 1. Okay, delta can be less than or equal to 1. Okay, delta can be less than or equal to 1. Can be less than or equal to 1. So the most x plus 2 can be is 5. That's the most it can be. That is, it's less than or equal to 5. Alright, so that's how you do one where it's not linear. Now, let's go back to one more. Let's look at another one and see what it means when we get an answer like delta is epsilon over 3 or what have you. What on earth does that mean? Okay, prove that and see what it means after. Prove that the limit as x goes 5 of 2x plus 1 equals to 11. The proof is very routine. Given any epsilon greater than 0, we must find delta greater than 0 such that f of x, 2x plus 1, minus the limit, which is 11, in absolute values, is less than epsilon, guarantees, implies that x minus c, this minus that, is less than delta. Well, the left-hand side becomes 2x minus 10 is less than epsilon. We want that to imply that x minus 5 is less than delta. This implication is only correct if we find the correct delta. But the left side, 2x minus 5, in absolute value, well, it's the absolute value of 2, which is 2, times the absolute value of x minus 5. That is, this here is 2 times x minus 5. And this is less than epsilon. We want this to imply that x minus 5 is less than delta. But this statement right here is exactly the same statement as the absolute value of x minus 5 is less than epsilon over 2. They're equivalent statements. They're equivalent statements. Because we divided by a positive number. I mean, if 7 is less than 20, if I divide the left side by 8 and the right side by 8, the left side, that is 7 over 8, is still less than 20 over 8. You have 7 pieces of candy today, and tomorrow you're not going to have 20 pieces of candy. 7, you have less candy today than tomorrow. If you're going to share the candy on both days with 8 people, today, that each person is going to get less than they get tomorrow. Alright. So you want this to imply that x minus 5 is less than delta. So if only delta said epsilon over 5, of course it'll be true. This is that epsilon over 2, excuse me. Of course, this is less than epsilon over 2. It guarantees that this is less than epsilon over 2. So you choose delta to equal epsilon over 2. Now, exactly what does that mean? So let's get rid of most of this. In terms of a graph, what's going on? In terms of a graph, what's going on? So delta is going to be epsilon over 2. So the first thing the statement says is given an epsilon. suppose I say epsilon is equal to a third. Okay? The epsilon is the y value. So we claim the limit is 11. And we're going to add a third, 11, this will be L plus epsilon, and we're going to take away a third. This will be 11 minus epsilon, and that's going to be what? 12? Couldn't be. That's going to be 10 and 2/3. L plus epsilon, L minus epsilon, and 11 is L. So here is my epsilon region. This here is my epsilon region. L plus epsilon between L minus epsilon and L plus epsilon. And now, since we're claiming that we choose or chose that epsilon is a third, well then delta is a third epsilon. The third, because it's epsilon over 2. But this is 1/6. Now, if you go to 5 and you add a 6, this here is delta. This here, that's not true. This here is C. This is C plus delta. And over here, we're going to put 5 minus 1/6, which is what? 4 5/6. Now, just so this works out perfectly, here's your line. Remember, 2x plus 1 is a line. And the line actually looks just like that. Now, what's going on is, so this is x and here's y. That is, x is here. I already had it. What I'm saying is that you tell me how close to get to 11. Remember I said maybe the answer isn't 11, the answer is 11.428? Well, I can show that it's not 428. I'll let epsilon be 0.33 forever, a third. So this is the upper bound for L is 11.333. What I'm saying is if I pick x values this close to 5, a 6 more or 6 less than 5, then I guarantee you that the y value, the limit, would be in between here. If I let x be between 4 and 5/6 and 5 and 1/6, that is 5 minus a 6, 5 plus a 6. L, the limit, will be within 1/3 of L. If you don't, you're going to say, oh, but 1/3 is pretty big. Not a problem. Not a problem. Let us change that value. Let us change it. Let epsilon be very, very small. Let epsilon be 1/1,000,000. Very small. Okay? So here we're going to have 11 minus a small number. And here we're going to have 11 plus this small number, a million. No promises I put the right number of zeros. So we're really close to 11. And I blew up the graph. That's why it's still just as much space. Well, I have to convince you that I can get that the y value is really in between those two numbers. Maybe I'm wrong. Maybe the y value can't be in between those two numbers if x is close enough to 5. So we know, if I remember here, we know that delta is epsilon over 2. Well, we're letting epsilon divide that by 2, I get 1 over 2 million. Delta is 1 over 2 million. That is, here is 5, and this here will be 5 minus delta. Here is 5 minus 1 over 2 million. And here is 5 plus 1 over m per million. 2m. 1 over 2 million. If x is in between there, I mean, to be honest, what's going to happen is the values are now even closer to 5. I'm not sure that that even came out. Since I let delta, I need to put this down. Since I let delta be even smaller, I'm going to be closer to 5. The x values are going to be closer to 5. Here's 5. Now 5 minus 1 over 2 million will be, say, maybe right here. And 5 plus 1 over 2 million will be right there. And of course, if I shrink down or make epsilon smaller, epsilon used to be a third. Now it's a lot smaller. It's 1 over a million. Okay, so here is 11. Here's 11. And right here is 1 over, is L plus epsilon. And right here is L minus epsilon. And what's happening is that if you look at all of these x values, consider those x values between 5 minus delta and 5 plus delta. They are going to end up, the y values are going to end up in between. Not necessarily from here to there. Not necessarily right in between. Not covering the whole L minus epsilon to L plus epsilon. But it'll be in between. In other words, if this is L plus epsilon, blowing it up, and this is L minus epsilon, I'm claiming that that delta region, L minus, 5 minus delta, 5 plus delta. These x values are going to end somewhere in here. It might just be that portion. It might be a bigger portion. It might even be the whole thing. But nonetheless, it ends up in there. That is, I got closer to L. L is somewhere in between here. And then if you let epsilon even be smaller, well then, this region right here gets even smaller, and this region here gets smaller, and the image of these x values end up in the smaller neighborhood of 11. Okay, so that's why epsilon equals, that's why delta can equal epsilon over 2. It guarantees me that if this is C, and this here is delta minus C, C minus delta, and here is C plus delta. If delta depends on epsilon, so I got this delta knowing what epsilon is, and you have some curve, I guarantee you that this region will be in between L plus epsilon and L minus epsilon. Possibly L minus epsilon might be right there. Possibly at the very, very top. That will be L plus epsilon. But nonetheless, everything in here was in my epsilon neighborhood. You make epsilon smaller, you converge in on L. It has to be L. L has to be 11. Now, what I do want to show you is What if you have the wrong limit? You may say, well, if I say the limit is 12 and it should be 11, I can still find delta. That's not true. If you look at the limit as x goes to 2, 3x plus 1, I think we did this one. I probably had the 2 and 3 switch. But in any case, this should be 7. 3 times 2 is 6, plus 1 is 7. I'm going to make a mistake. So I must show, given epsilon greater than 0, that we can find, given any epsilon greater than 0, I can find delta greater than 0 such that after of x, 3x plus 8, 1, minus the limit, 8, in absolute value, this is less than epsilon. That guarantees that x minus c is less than delta. The problem is you're never going to get this to look like that. This here is 3x minus 7, less than epsilon. You're never going to get this out of it. Since I want x, you may say factor out to 3. The problem is then I get x minus 7 over 3, which is not 2. This is not 2. And that's where the definition isn't living up to, you can't find delta. You can find the delta. Why can't you find the delta? The limit's not 8. The limit's not 8. Okay, I hope this was clear. Some instructors teach delta epsilon proofs. The majority, unfortunately, do not. Okay, good luck with it.